So, okay. So those who are working with your own computer, did you manage to get the Octave or Octave, however you would pronounce it? Did you manage to download and log it? Load it and log it and run it. Okay. There's one known issue about the Octave. It's the graphics. There are actually 3 different graphics environments on Octave that actually one of them may work. However, warning. I think, are we running Windows 10 already here, or is it Windows 7? 7, okay. I checked this morning and neither of those 3 packages worked on these computers. There are some issues. But anyways, there are also some instructions later on what you could actually try there. And of course, with the Octave, the best thing ever is the Google, and just Google your question and you will probably get the answer to your question from either directly from the SourceForge pages or some of those discussion groups. Okay, are we recording? Yes, we are on. We are live. This is live, Saturday Night Live, directly from Leppävaara Studios. All right, so basically what we are going to do today on these labs is to go, oops, sorry, I want to have the viewing kind of thingy going. So today's laboratory is about signal fundamentals, and if some point today it feels like, oh, these are so stupid, don't worry, it gets much harder next week. But if sometime this afternoon start to feel like, oh boy, I'm stuck, I'm here to help you on your stuck thing. Okay, so there were also students who has never used Matlab. Yeah, okay, it might be a little bit, awkward to go this kind of tool right now, because basically the fundamentally Matlab is from 80s. Worked in digital equipment, VAX, VMS, mainframe computers as a demonstration version while it was still totally free academic project. And that was year 84. A lot of time has passed. It's not free anymore. It's the most used mathematical tool in industry. And yes, in industry there are Matlab users. What else? It's also the most used digital signal processing the tool of the time. It's used for everything. Anyhow, that's enough for Matlab. Basically, today's exercise, when you click that link, I just made small minor change. If you actually downloaded this one, say 5 minutes ago, please go and refresh that window, since it might have changed in between. Okay, so exercises, these are at the same time templates. This is a Google document, and you can make your own copy of it. Right. Since there are the questions, and then there are places to put your own answer, but you can put your own answer on your own personal copy. And this is also a good place to start practicing, Google documents. Make a personal copy of it. As you can see, there are placed for 3 different names. So yes, you can work on groups up to 3 people. And when you are one has made the copy, make sure that the other 2 can access the same copy. For example, share it for collaboration, or share it for read and write with your partners there. Okay. Then there are some instructions. Let's take a quick look at the what kind of instructions have I here. Okay. Is it broken link? No. All right. There might be some details still a little bit different from, since this originally I made these instructions on, let's see, 2006 or 7 or something like that. So this is at the same time it's frequently asked questions, answers to those. So working instructions are quite simple. So start Matlab or Octave, whatever you are using. Create a new working directory and make it your current directory. Let's do that one. I will start the Matlab here. You start it there. Okay. I don't find it here. So Matlab. 2015 version, so it's quite recent. Takes a 10 or 20 seconds to start it up. Or maybe 30 seconds. Okay, while it's starting, see, it works every time. You should get something like that. If you are working with the Octave, you have similar view. But evidently I need to make fonts bigger and that kind of things here, but I will do it later. So as you can see, the interface was done in 80s. It's command line driven interface. There's not that much things to click and, you know, click and clack. So most important feature of Matlab is that it's command line driven environment. Another one, okay. I said something about creating a directory. So basically you can go to a directory and even, I think you can even, so that's users, authenticated documents, Matlab. That's actually quite okay directory on these computers. On your own computers, it's up to you where you put things. But I would say I will put this one. Let's see if I can create folder. Yes, I can create a folder. Exercise 1 and just go there. Okay, that's the working directory. You can do the same thing in Octave. All right. And then make an editable copy of the worksheet. Okay, so that one, and under File, make a copy. Make a copy. After you have done the copy, it's on your own Google directory. I don't care where it is. Just remember to share it with your co-workers there. Then, of course, names. Name 1, name 2, name 3, not more than that. Put the contributors' names there, preferably so that I can recognize and match it with this list. Okay, no nicknames here. Everywhere else you can use your nicknames, but not on the return. Okay, then it's quite obvious what to do. Then you would go and start working on the exercise together and basically fill the yellow parts here there's the question, and then you should write your answer to the space there. Why I'm asking everyone to use the same form? Because, well, there are some students here, 30 some students here. There will be also about 100 other students from other universities. Okay, and if I see a similar sheet, then I can directly go to the questions and answers, and it takes only, say, 30 seconds for me to go through and grade your stuff. Okay. If everyone did your own kind of documents, then I should start looking with this magnifier lens where the answers are. So that way, this is just to make my life easier. Okay, and after you have done everything, you should save the document and share it with me. Or actually, well, I hate if you share it with me. I would like you to return it by using this form, since otherwise, you know, files shared with me would exponentially grow so that I cannot see anything anymore. So I have a Google form that where you can basically first click which, oops, is this, no, okay, preview. It looks like this. So you choose your university, Metropolia Hochschule Bonn, Rhein-Sieg, or Vilnius Gediminas Technical University. Well, guess your own university where you are studying now. And then names. Okay, I need at least one name there, so that I can identify, just in case there's something wrong with the return. I can go, hey, wait a minute, there's something missing. Okay, technically. Otherwise, I read the whatever names you have on your on the return sheet. Then, yes, exercise, which one are you returning? Before next Monday lab session, you should return the first exercise. And then how? Just write the link to the answer. Okay, link to answers. So make the your document, share it with anyone with the link. So with commenting properties. So if there is something wrong and you want to know why didn't you get all the points, I will actually write there the comment. Okay, if you don't share it correctly, I automatically degrade it by 1 point. Okay, so this is just to make my life easier. Remember, you know, feel me, I'm teaching a lot of students here. Okay, so yes, those 4 questions and link to answers is the most important thing by the deadline of the study. And basically, when you are working together, you are basically also sharing together. That's one part of the sharing is 10%. So working automatically gives you 10% of the grade already. Haha. If you prefer to work alone, then I will actually make you to share to each other, so you can start commenting each other's work. I might actually do it for everyone, since it's fun. You know, just give links to Chris and Cross, and then you can start sharing the ideas and telling what was wrong there, or giving good hints how to improve it, and so on. So it works actually, believe me. Okay. Does it say anything about the one important number here? Ah, yes. Instructions are made so that you at some point should go and read them carefully actually. In some exercise, like in first exercise 1.9, you need a number SSS, which is a semi-random number, which is last 3 non-zero digits of your student ID number. That gives you more or less unique number between 111 to 999 for each of you. Non-zero digits means there are no zeros on that one. So if you have some zeros, you just leave them out and take the next non-zero digit. And working together, you can pick somebody's secret number and just stick on that one the whole exercise. Okay, but clear? Everything is clear this far, right? Well, the instructions are there, so if something's not clear, then you can always, come back to it. All right, and what kind of things I actually asked there? Write the comments, write the comments. Yeah, that's quite simple. It's cut and paste. Then there's also something like that. Insert the figure here. Okay, you can copy paste also pictures to the document in different ways. And then, okay, one more thing today is about when you are generating on 1.9 a sound sample, simple sound sample, you should actually provide a link to your sound sample. Okay, save it to Google Drive or, well, Dropbox, whatever location that is accessible by browser, and insert a link here. And one small thing. Hi, Joe. Looking for something? No? Oh, I have full class here. Yeah, awesome. Yeah. Oh. Yeah. And you even had a chance to get out, during the lunch. All right. So save the sound sample. Okay. When you are giving some links to me, the easiest way of getting a penalty on points is to not check the link with the browser before you send it. Okay. Usually, say first, exercise return. About 20% of the students in past, they forgot to put the privileges right. So I just get the link, but I have also access denied. Okay, that means -1 point. Okay, second submission, still the same problem on this one. Save the sound sample, but privileges not correctly. Another point. Okay, so just careful, check the links with a clean browser, meaning non-login to any system, but for example, this Windows Explorer, which cannot be used much of anything. Use that one without any logging into any Google or so, and check the links that they actually work. They'll be perfect. Good. All right. Back to basics. So I already took the whiteboard pictures, and let's see if I could do the yeah, I think you can already access these, maybe. So I have the whiteboard pictures going to one place. That link is already there. Okay. At some point, we also have the video of the lectures there. And then I will also add a link to the exercise video. Exercise video, yeah. Okay, and also the whiteboard pictures if we had any. In addition to that, whatever I do on Matlab, I will put also the command history there. So you can concentrate, you know, my big show here. Don't need to make your own personal notes unless you really want to. Or you can actually concentrate starting doing things with the Matlab. All right. And yes, there's also the deadline. Deadline for this first exercise is before next Monday noon. So when the next exercise starts, that also means the deadline for the previous one. If you miss the deadline, there will be a penalty of -1 point. And use the return form on that link. Good. All right. Let's see. I need to find the where's the fonts? All right. I just made my font bigger on that command window. So today's topic was actually the signals. Oh, any question? Ask those guys if they have any questions. Any questions? Okay. Today's topic was about signals and the basic signals. So basically, one basic signal was the Dirac's discrete delta function, which was defined as like that, and it looks like 0, -1, -2, 1, 2, 3, 4. It looks like this one. So how to actually make Matlab to understand we have this sort of data sequence at those points? I would start by saying, okay, this here is so-called index n. Then we can actually index that delta so that set the value so that whenever the n equals 0, then we have 1, otherwise 0. All right, so let's try the next one. First of all, now I should have the is there any box or something like that? I need to get this one a little bit higher. No. This lab is almost perfect. All right, so first things first. When you have Matlab running and you want a comment, you can start it with the %sign. Comment, actually this is the same as // in C. So everything after that, it will be commented on that same line. And then, for example, I could create a vector n. Are those guys actually disturbing you? Okay, if not, if they start disturbing me, you know, I can get rid of those. Wink, wink. Okay. Yeah. NN would be my index vector, and it should actually go from -2, -1, 0, 1. And you can do it, of course, like this. A brace to say this will start a vector -2, -1, 0, 1, 2, 3, oops, that'll also do 3 and 4. That should be exactly that index vector here. And all right, and well, now it repeats, okay, n equals that. You can also see the variable on the workspace window, and basically this is Matlab feature, not in Octave. You can even edit that table on Matlab. Octave has some limitations there. Anyways, then that's kind of, if you have, say, 1693 samples on vector, it's kind of boring to start typing them. You can also use so-called auto-indexing. Same thing. Start from -2, ending to 4. I also put semicolon there, which suppresses the output. So this is actually from 2, step size is 1 by default there, and then this semicolon means no output to screen. Oops. There. It still does the same thing in workspace. All right. So now we have an index. How to create this one? Using the definition. This is one way. Delta equals to. We test if this index vector goes to 0, then it gives value true, not 1, but true. This is kind of C kind of thing, so this is quite dangerous operation usually, to just directly put the values from, casting values from logic to numbers, since you never know what kind of values the true has. Since in C, what is the false? 0. And what is true? No. Anything else but 0 gives true. Okay, so this is dangerous. Although it would work, but you can also use casting to double. Now it's not anymore logic, but it's actually a numerical values. And this testing where n equals 0. Yeah. Okay. DD. Next we can start plotting. If you install it Octave, it might actually hang right now if you do the next command. If it does, there are some instructions actually how to change the graphics interpreter on the Octave. Fundamentally, let's see here, Octave packages. Where does it say? Okay. You might need to change the graphics toolkit to GNU plot. The default is some FLTK. There's also Qt toolkit in this one, so Qt is not dead. It's just transferred to another place. Okay. Since I want to see this kind of plot, this is called a stem plot. How do you remember the stem? You know what the stem is? For example, a flower. The stem part is this part here. That's the stem plot. And simply write stem here. Okay. If you just put this function name and then start the parenthesis there, it actually gives you different ways of using this stem function. Also, you can get more help. Matlab used to have the best help files in the universe. Seriously. Not like Windows help when you have a trouble in Windows and you try to get help on that one. Where do you go? Your friend first, and then IRC gallery, and then some other social network, because usually those Microsoft, no offense, Microsoft help does not help. It just say, okay, call to your system administrator, even if you are yourself the system administrator. All right, so stem, X and Y. This is our X. Horizontal information is our index, and then Y is our values, which is the delta on DD. So stem NN DD. There you go. Stem plot of delta function. You got it. Ugly. It's okay, but it's ugly. Just to tidy it up, can you say what is the problem with this picture? Yeah, it's hard to read because, well, it's not the box like this, but all the data is actually on the axis. So let's change it a little bit. Just for fun, I will just dock it here so you can see what happens. First, I would like to little bit stretch the axis so that, for example, from minus 2.5 to 4.5, and then Y minus 0.1 to 1.1. Then the data doesn't touch the axis anymore. And there is a command axis. Okay, so did the stem plot work? Hyvä. Mä otan uudestaan shown jälkeen, käykö näin? Uusinta. Noniin, hyvä. All right, so basically that's what you get. Yeah, the last one, the laughing, it didn't really translate. All right, so that's the picture. Next, what we could do is actually add some labels there. X label is index, N. Oops, sorry, I always forgot this one. On Octave, you can use that double, but on Matlab you must use just that one. What is that called? Yeah, there. Index N. So strings are actually just, you know, that prime text prime. And then Y label. I did some magic here. Value. There. Now it has labels. Then title. If you have a string value, then you can put just it after the command. There. Whoops, sorry. I thought that I could, but I cannot, evidently. Yeah, there, discrete delta function. Okay, that looks like a decent picture. Let's save it. I will undock it. Where do I get actually up? And what else it has actually, I think I can just take the strange. I should be able to take a picture of it. Link plot. Huh. Insert, show. Save, open file, print figure. Or at least we can save it at least, for example, as bitmap. Or okay, what is the your favorite graphics form? My favorite is portable network graphics, which works everywhere. Portable network graphics, and it does not have any title, so I'll just put example 01. There. Nice PNG file in here. Let's take a quick look. Open outside of Matlab. Yes, that looks like OK file for document. And you know how to put this one as a picture to your document, I think. Yep. For example, copy, and I like copy pasting and just paste wherever. Let's see. Ooh, copy and paste requires Google Drive app. Well, nothing happened here. Excellent demonstration. All right. It took for a while, but this is something. Control-C, Control-V should basically work, but well, at least it works like that. But that was just an example how to work. I'll just remove it here since. Okay, we are just going through the examples here. So discrete delta functions like that. Good. How about then the other function, the unit step function? that one. It's quite simple, right? If here the test was if we test if the n equals 0, then that's true. Here we just replace it with the greater than equal to. Let me close that one. Okay. So that will be u equals. Oh, okay, I will show you something. That's way too many things to type. So you can always press couple of words first, letters of your command, of the previous command, press arrow up. It will actually find the commands which started with the those. Those. And then, you know, control arrows will work, you know, stepping word by word. Oops, not. Control A, I think was, oops, no, control something was the beginning of the, okay, there. UU equals double NN, not equal to, but that one. Testing where n is greater than equal to 0, and that was the unit step function. And we can stem that one too. UU there. Do the same magic for the axis information. X label, Y label, title. And where is my window? Plots. Oh. Here. There we go. So that was the unit step. The only difference was that how to generate it. Another thing we need to do once in a while, and a lot actually, is the delay function. Okay, how to delay, for example, so that we don't have h of n, but say h of n minus 2, which means it has 2 steps, 2 index time delay. So the signal actually starts later. The safest way of doing it would be, I'll just make a new value here. Well, by the definition, n minus 2 greater than equal to 0, this gives 2-step time delay. There, and seeing is believing. There, now it starts from index 2, right here. Okay, so now we can basically, those are the basic things how to manipulate index vectors and these basic functions, step, unit step, and the unit impulse. Then you can actually start playing with these functions, but let's make a sampling, sampled data. And my favorite sampled function is actually a exponential decay. All right, and we start from the real-time system. Say we are measuring the step response of an analog system by running a step into that one, and for example, if we have a RC high-pass filter, it would give us this kind of signal out, right? So this is there. Square wave. So most important thing here is this this big step, and that will be exponential, say U out equals some initial value times exponential of minus t over RC, for example. Right. Okay. So now let's think that we have this kind of measured signal and we have oscilloscope data, what it should actually look like. Not the crappy one what we get from the real oscilloscopes, but this is already, we are kind of making a perfect life, perfect system without any errors, what it's supposed to look like. Simulation, that is. And we can actually, this is this kind of simple function. Let's put here some values like sampling time. 1 millisecond sampling time. So sampling interval would be 1 kilohertz. Okay? And then R times C, time constant for the system. These guys. Time constant. Give me some time constant. In milliseconds. How many milliseconds? All right. I will just put here, well, to make it this easy, I'll just put 1 millisecond time constant for that RC filter, which means 1 kilo resistor and 1 micro capacitor. That gives you 1 millisecond time constant. Okay. That's a sampling time. That's a time constant. Now we just need to sample it. Okay. So we have the u of t equals some initial value 0 times exponential of minus t divided by RC. That's quite simple. And now how do we sample? Actually, whoa, something funny is happening there. Tell me. Okay. All right. So sampling actually is just we replace the time t with. Whoops. Whoops. Why this keyboard does not like me? That was the sampling theorem. Okay. U of n is actually U of n times t. Now we have something to calculate. Right. We have n, this one, sampling time 1 millisecond. So we can start with the nt, which is basically the sample time vector, n times 1 e to minus 3. and then evaluate that function on those points. I call it EE. U0, well, just one. One is just enough. One amplitude exponential of minus nt divided by RC was 1 e minus 3. Right? That's the sampling. Let me close that one and move it a little bit higher. Can I move it? No, I cannot. Sorry about that. All right, so that is the sampled exponential function. And there. Now we can again stem plot it. Okay, what is wrong with this picture? What is wrong with this picture? Yeah, this is just right part of that one is okay, not the left one. If you had done this exercise hard way with the Laplace transforms and such, you know that basically what is missing here is the step function. The initial condition of system being 0 before it starts, that's done by the step function or the Heaviside function in reality. So it means that we still have to put the step function into our output. Then it will be correct. Let's do that. EU. Oh, that's fun. EE. And multiply element by element. If you put multiplication mark here, it actually gives you error message because of the vector sizes do not match. Matlab by default actually calculates the if you have vectors, it calculates vector product there. So two vectors, then you have to have, you know, other one this way, another one that way, or that way. Okay, so here you need to actually do element-wise product multiplication dot times. Dot operator actually is if you put dot in front of any operation, it means element-wise operation. Element by element. There. Whoa. Now it starts from 0. You. Okay. Better. Now we have a simulation of RC filter samples from sampling oscilloscope. Not quite there yet. Life is not that simple. We also have always some noise in the data. Okay? So noise means random values. And this is natural process, so it's either Poisson distribution of or the normal distribution, and in electronics, as here, it's usually the normal distribution noise. So we need also to add some noise to our data, then it actually looks more like the it will be real kind of thingy. Some noise. And basically the rand n size of nn will produce you a vector which has same size as nn and normally distributed random numbers with zero mean and deviation of 1. Okay, which is quite a lot of noise. Let me show you how big numbers they are. Okay, there. So that's quite a lot of noise. But how about if we now estimate the signal to noise ratio, set the signal to noise ratio for that one. Or another way actually would be to estimate the quantization noise of the system, saying, okay, we have 8-bit converter, which means 1 is divided into 256 points. Yes, 256 different parts. That would be actually something. Okay. Of course, the quantization noise is not normally distributed here, but with big numbers it will be about the same. Right. That would be somewhat the noise level if it was the same as the least significant bit. Now we have some noise. And then we can, of course, plot it. Add. Plus the noise. There we go. So we have a little bit of variation there on the values. But you can see that actually from those left-hand side values. Okay, but that's the process how you add some artificial noise to samples. Okay. So delta function, step function, sample data. Sampling is simply basically t equals n times capital T. Simple. So fundamentally we have the all the information you need for the 8 first questions right here. Okay, last 2, it's about sounds, and sounds with sampling rate higher, which means that this doesn't sound much at all if you try to hear it. Let's try a little bit different. The chirp sound actually is a good one. Chirp was actually a data or a signal that starts from some basic frequency and ends at some other with some sampling rate and such. First of all, let's check or take a reasonable sampling rate. For example, how about 44.1 kilohertz? Okay, sampling rate 44,000. So that's CD quality audio sampling rate. Yes.
I got a little question from a little while back.
Okay.
Why did you use e to the -3 for your?
Oh, sorry. That's the engineering notation of the floating point numbers. Yeah, sorry, I didn't pay attention to that. I'm so old guy, so that was obvious to me, but never thought about. Okay, that's the age of typing. I'm a dinosaur. I know. Okay, so it's 1 times 10 to -3. Okay, sampling rate 44.1 kilohertz sampling rate. Then we'll check the chirp. Let's take first the help on chirp. Ooh, I got a lot of examples here. Swept frequency cosine generator. So the first way of using it generates samples of linear swept frequency similar at the time instance defined by array T. So for each of those time values, it generates the chirp value. The instantaneous frequency at time 0 is the F0, and instantaneous frequency F1 is achieved at time T1. Okay, those are F0 is 0, T1 is 1, and okay, blah, blah, blah. So in plain English, you have to put there time vector. Oops, no, let's. So we need time vector, sampling times. Fundamentally, it's n times t. I will show you also another way of producing it. Then it starts from F0, yeah, it's here. Stop at F1 at the end of times, right? Yes, and what else? That's all. For example, from 0 to 1.2 seconds, 2 frequencies. Another one is 440. Give me some higher frequency. Anyone? Reasonably higher frequency. 800. Yes. Why did you pick 800? Okay, good. Anyways, it's a good frequency. I picked this one because it's note A. Okay. Yeah, let's chirp. And for chirp, we need the time vector. T. Now we have the sampling frequencies 44.1 kilohertz. The sample rate, the sampling time let me do this one over, since sampling time is 1 over sampling frequency. Sample time, so time interval between the samples. And now I can use the auto-indexing again. Time vector from 0 with the time step of ts up to 1.2. So this is the second use of the colon operator. So it's from step size 2. Replaces basically for I equals to something I plus something in C. There. That's a sample time vector. How many samples I do have? Oh, wow. That's 52,921 samples in my thingy. Okay, so next we chirp. Chirp. Time vector there. F0 is 440 hertz. T1 is 1.2, for example, the end of it, and then F1 was 800. And let's save it to somewhere. C. Plotting this does not make much sense. I'll show you how. Why? Don't.
You know that same command for the okay.
Yeah, chirp. Yes, you just probably need to download first the signal packages. Let's see. It's somewhere. Try package install signal. Yeah. pkg install dash forge, and then you need to also load it after installation. Yeah. All right. I'll plot it just for fun. TTCC. Not too informative picture, right? Because if I go closer here, in the beginning, okay, it's just sinusoid with the starting frequency and then with the ending frequency. Boring signal unless you listen it. Next we will see if these loudspeakers are actually working. Ha! Yeah, that was chirp signal. Cool. Now everyone can make at least chirp signal to your mobile phone signal. As soon as you can save that, of course. And you can save it. I'm old guys, which means that I like WAV files. Okay. I shouldn't have taught you how to do this. You certainly. Okay, wave. Right. All right. How does it work? CC sampling rate. File name. You can even define the number of bits, but well, I think the Matlab can do guessing there. FS, and this will be sound example. Dot wave. Oops. Okay. Yeah, error. WaveWrite will be removed in future release, and it also gave me an error. Maybe I should use AudioWrite. I'm too old for this, so let's see. Another way of having help, since this help function gives you help on the screen, command prompt screen. If you need more comprehensive help, try doc and the function name. And this is what I told you, the Matlab having the best documentation ever, or at least it used to have. Now there are a couple of features there, but we will bounce into those features later. It's basically multiple file names, or multiple function with the same name. Okay, there, our AudioWrite, and it shows you the syntax and everything, including some examples and cross-reference and everything. So if you ever have to, or well, if you ever get a job of documenting software, take a close look at the Matlab pages. These documents, they are just absolutely wonderful. All right, so WaveWrite. Oh, it also has some handle here. AudioWrite. File name first. Y sampling rate, and then we need to also define the wave file. Let's see. How does it work here? Bits per sample, sample rate, bitrate, quality, title, artist, comment. Inclusive file extension. Okay, let me just try it like that. I think this will save me a WAV file. Yeah, at least it says it's WAV file on the, and then of course I can check if it works. Sound example, double clicking. No, I don't want to do that. Let's see. Open outside of Matlab. Oh yeah, it's the same. Okay, so I can generate different kind of sound files in Matlab and save it at least in WAV format. There are also some other formats. You can do the same thing also in Octave. And now you can, well, next time you come here, you probably all have the same word as your ringing tone on the phone. Would you like to hear my ringing tone? Okay. Let's see. It takes for a while. Settings, sounds and notifications, ringtones and sounds. I can recognize it anywhere. Nobody else can. Haha. I call it smiley. For a reason I'll show you next time. Okay. In my point of view, I have done my show here. So rest of the time today, work on the exercises either alone or in pairs or in max 3 persons. Of course, you can also work together, but what I really want you to do is to make a nice report based on this exercise form with your own unique answers. You know what unique means, so that I cannot find exactly the same from another paper. Right, unique answers. Do you know how many points I take off if I start finding exactly the same answers? You don't want to know about it, so do the math or do the exercises, and we will see next week. But I will be hanging around here until at least 3:30 or so. So yeah, there you go. That's it, and that's also closes the session for the recording. Yes.